Okay, thank you very much for this very clear, precise, and informative presentation on the state of the art of CRISPR editing. We have time for a few questions before the coffee break. So I turn the floor over to you, and if you want to ask a question, please raise your hand and press on the button mic, which is to the right of the microphone that you have, and also when you ask your question, to present yourself briefly. So the floor is yours. Questions, of course, regarding the discussion by Professor Mojica.
I will ask a question, which is after this splendid presentation, it's clear that you made crystal clear the state of the art and all the road to find new CRISPRs or new ways. So now, from your seminal work, how do you see the intellectual property about genome editing, and what do you think what is natural and obvious for people in the art, and what do you think should be patented or should be a matter of patent in this field, if you have a view on this point?
Okay, I'm not an expert on patents. That's evident, because if I were, probably I would have got a patent a long time ago. So anyway, I think patents are necessary to convince some people that have to invest a lot of money to get these tools at least applied in therapeutic applications. I think they are necessary. The only problem, I think, is that sometimes people want to get a benefit in institutions where that's the main subject of their incomes. I mean, it's a great source of money. And that means that there are sometimes fights, very heavy fights, to get the rights for a patent, that eventually someone will get it, but in the meantime, everything goes slower, too slow, in order to get people involved in investigation with these tools for therapeutic applications, because it's uncertain which is going to get the patent eventually. That's the only thing I can tell you. I'm not involved in patents. The good thing of not getting an economic reward and income from that is that you can have a free thinking on that, and then I'm not biased at all on this opinion. So that is what I think, what I heard from people that is complaining about this sort of things. Like I said, patents, unfortunately, are absolutely necessary. But what is very bad thing is that there are fights against fights to get this sort of patents.
Agnès Saint-Raymond, European Medicines Agency. Thank you very much for the presentation. It was very clear. You started from the defense of the bacteria against viruses. Of course, this has a very important impact potentially for us to treat infection and antimicrobial resistance potentially in the future. Do you see that as a way to approach antimicrobial resistance? And because then that would make the link between this and potentially also the ethical aspect of making humans resistant to infection and starting to make a difference in the genome that we have, having some sort of superhumans would resist infections.
Okay, that's one possibility. Plants have been already engineered with CRISPR to get them resistant to infections. The problem with viruses, that is, okay, you can fight against viruses with the CRISPR-Cas system because the DNA of the virus gets into the cell, so you can get there a resident CRISPR system that fights against the virus. That can, in theory, that can be done in any organism, including humans. but that's not very useful as such, because this is not an adaptive system if you only include this Cas9, for instance, and guide, a program guide, because viruses change a lot. So you should transfer the complete adaptive CRISPR-Cas system of prokaryotes to human cells. That's going to be a very dangerous thing, because this adaptive system takes pieces of DNA from invaders, but also can take pieces of DNA from their own genome. And the result of that is that the cell will die. In humans, the result of that, talking about bacteria, in humans, the result of that, taking pieces of DNA, their own DNA, will be mutations, the production of many mutations. So it's not possible to move that to humans. But you can get a pre-programmed immune system in humans. Not useful at all.
Uygar Tazebay from Istanbul, Turkey. My question is about the biology of CRISPR-Cas in microbial systems. I was wondering whether there is also a horizontal gene transfer among bacteria, so that could they share their memories among themselves also? Is there examples of that in the biology of microorganisms?
Yeah. So prokaryotes are very promiscuous. They just they mix everything. They don't have any sexual barrier, and they get DNA from whoever that is in the environment. So the horizontal transfer of DNA happens quite frequently. In fact, the CRISPR-Cas systems are transferred frequently, let's say, between prokaryotes. People used to say that CRISPR-Cas systems are immune systems, myself, but that's not really correct. CRISPR-Cas systems are barriers, genetic barriers against any DNA that gets into the cell. So that explains why only 50% of prokaryotes have a CRISPR-Cas system, and those that have a CRISPR-Cas system have it under very stringent regulation and only turn on when it's really necessary. So CRISPR are genetic barriers against horizontal gene transfer that happens very, very frequently in prokaryotes, and that is very necessary for prokaryotes to evolve. For instance, you will see that with a clear example: antibiotic resistance. Bacteria get resistant to antibiotics by mutations, random mutations, or by acquisition by horizontal gene transfer from other microorganisms. So that's absolutely necessary to survival in some environments and also to evolution. And CRISPR are a barrier to that also. So I think I answered your question more or less.
Alexa Greenbaum, CA France. You talked about editing instruments, and you took examples of their use in therapy. You didn't mention gene drives. Is there a reason for that?
No, the reason is that I only have half an hour. So, no, in fact, initially I had about 100 slides, and I removed 60. And gene drives is one of the uses or applications of CRISPR-Cas9 technology. You can modify mosquitoes, for instance, to get them resistant to malaria, and using CRISPR-Cas9, in theory, in a few months, all mosquitoes in the area will be replaced by these mosquitoes, CRISPRized mosquitoes resistant to malaria. That's one possibility. I just heard someone working in the field that said that that's the theory, but the reality is not just that. They are not going to replace all the other mosquitoes in the field. That's an example of mosquitoes. I could be talking about any other thing. So, of course, there are many worries stories related to that. But it's even worse probably focusing on this case, mosquitoes that are not able to reproduce and that will kill all the species of the mosquitoes in the world. And probably it's much better just to get still mosquitoes there that will feed some birds, for instance, that are modified and they do not transmit malaria, for instance.